Okay, so in this video clip, we're going to set out amortization function, and we're going to set that up in this Google Colab, which is normally a Python notebook. And we're going to run some Python script and R script, both for the mortgage payment and for the amortization. And then we'll take the mortgage, the R function that we've borrowed here from Sean Jacob Wheeler, and introduce it as a function into Excel. And there's some additional script here in R from Thomas Girk, and I'll leave the link to Thomas's portal, and we'll interpret the visualization then that he provides for his estimation. So the set of numbers we're going to work with, and the problem we're initially going to address here is just a basic problem. We have a borrower wishes to take out a mortgage of €120,000 for a term of 30 years. What is the monthly repayment if the fixed rate is 5%? And what we basically have here, we have an amount that's being borrowed. We have the maturity, or the number of years that the mortgage is going to be set up for. We have the frequency of the payment during the year, so 12 times a year, so the payment is going to be made monthly. And then we're assuming that the rate of interest on the mortgage is fixed. And from that, then we're going to generate what the monthly repayment would be. The logic here is simple enough. The maths is basically, we're going to use an annuity structure, wherein what we have here in the square brackets is a present value of annuity, where basically we have 1 minus, open brackets, 1 plus the rate of interest divided by the frequency of the payment in the year, close the brackets, to the power of the frequency times the number of years. So the frequency times the number of years, that's 360 payments are going to be made during the life of the mortgage. And then underneath the line here, we have another ratio, same as before, the rate of interest, fixed rate on the mortgage divided by the frequency of the payment. There's only one unknown here. It's the monthly repayment. That's what we're trying to estimate. To isolate the payment, we divide both sides by what's in the square brackets. And it cancels out here. If you bring over to the other side, you're dividing that 120,000 by the square brackets, and we're getting payment, then a monthly payment of 644. Now we can check that. We could go into Excel, set that up. I'm going to wait a moment. We can do it here in Python. So just a few things to note. As we're going through the estimation here, we will run the Python script and an R script and set up an R function. This is coming in again from Sean Jacob Wheeler. And because it's a function, that means we will be able to run that as a user-defined function. And we'll introduce that into Excel using the BERT add-in for Excel. And then we'll do some additional visualization looking at the behavior of the interest and the principal as components of the monthly repayment, the fixed monthly payment. And that we have a link there to ucr.edu, and this is Thomas Girk's function that he has provided here. So, okay, let's take a look then at the, just very, to get the ball rolling, to look here at the payment. Can we verify that these figures actually are correct? Well, I've come down here and I've basically taken on board the information that's provided, that it's the amount we're going to borrow is 120,000. The frequency of the payment is 12, so monthly, 30-year term. Rate of interest is 5%. And we're saying that the square brackets, we create an object here, and we're saying the square brackets is basically what we have here. The present value of the annuity is the square brackets. And we're saying we're going to divide that into the mortgage amount, that's the 120, and that'll give us the monthly repayment, which we have here is 644.1859, which is the same as what we have basically here. Okay, so that no problem there. If we just execute, remember Google Colab, which is what we have, we're executing the code here. The Google Colab is normally using Python code. Now we want to run some R script in this Google Colab. In order to achieve that, we can use this magic cell. And if we load in this simple command, and then if we use then the double %R notation, we can run any R script or code. So basically taking the information that we were provided with initially, if I run this R function developed by Sean Jacob Wheeler, and maybe we can follow the link there in this instance. It's from our bloggers, and the function is set out here, right? So you might follow that up and take a quick look. If we run that function, keeping in mind in order to run an R script, we must put in this double %R notation, and the values here are the same as before. The amortize function uses the principal input, the interest input, the number of months, and then we have an output table, right? So in our case here, basically what we're doing is we're saying the amount we're going to borrow, the interest charged, and it's fixed, the number of months, and then we have that table, right? And if we run that, we get our mortgage schedule. Okay, and basically the amortization schedule is giving us a breakdown of the amount of money we initially borrowed, the monthly payment, which is fixed, and then we break the monthly payment into the principal component and the interest. Typically at the beginning of the mortgage life, you're paying mainly interest, and then afterwards the interest component starts to get less and less, and more of your monthly repayment is going on amortizing the loan. So you're reducing the amount of the principal on the mortgage as we make those incremental payments. Okay, so let's take our snippet of code here, and we'll set up in RStudio, and then see if we can replicate that into Excel. So we'll copy selection. We'll go into RStudio. Open up RStudio. We'll create a new file, new R script, and we'll paste Control V, and we'll run our function. Let's save it. File, save as. And if we're going to save in the documents folder, and it's probably worth noting the add-in that I'm going to use here is coming from the BERT add-in. So if we look for BERT or add-in, right, it's this add-in that we're going to use so that we can take our R function, save the R function into the BERT2 folder. So File, Save As, and we're going to save into the Functions folder, and we should give it a name, Amortize. Amortize, and maybe I would put Sean, A-U-N, right? Okay, so let's save that in the Functions folder. And make sure we run the function, right? And we get that output, right? So, okay, let's save that, File, and save. Now, because it's saved into the BERT folder, BERT2 functions, if we come in here, we can see amortize shown as there in that folder. We can now go into Excel, and the original estimation is here, right? Borrower wishes to take out that amount of mortgage for a 30-year period. What's the monthly repayment? And in a previous set of video clips, which I'll leave a link to below this video clip, I explained how in Excel you would set out an amortization schedule. And I went through the process of demonstrating, okay, if we have this 120,000 and it is 5% and it's 12 and we have 360 months of payment, that would be 644 per month. The square brackets, the present value annuity factor would be 186 given these parameter inputs. And if we were to visualize the portions of how much interest and how much principal is being amortized, I'd set that up in Excel, and we were able to see that after 360 months, machine's a bit slow for some reason. After 300, I paused for some reason. Okay, let's pause the video until that fixes itself or resolves. Okay, so let's go back again. Now, it's basically, if we look here at the schedule, we have 360 months. Let's blow it up a little bit. I went past. Okay, maybe the best thing here is view and unfreeze. Freeze pane, split. I think I have to remove the split. Okay, so you can see when we come to 360 months that the principal what we had paid when the amount of money that was remaining in the mortgage, it went to zero, and that the interest element, so the monthly payment is fixed at 644, but there was an interest, there was a principal element and an interest. And as we get closer and closer to the mortgage coming up to 30 years, so 30 times 12 is 360 months, the balance outstanding in the mortgage goes to zero. So the other numbers that we have below here, we just don't need, right? There, it would be as if we had started to pay the money in excess of what was required, right? So the graph that we have here then captures the interest component and the principal. You can see that the interest component gets less and less over the life of the mortgage, and the principal element increases. So each month you pay 644.19. The principal element goes up, the interest element reduces. Now, if the interest payment was much less, you can see if the interest was really low, most of the payment you were making during the life of the mortgage would have been on principal and less on interest. During the 1970s, 1980s, interest rates went up to 15 and 10%, double digit. So if the interest rate was 10%, you can see starting off here, most of our payment is actually interest. And only after getting way into the mortgage at maybe close to month 300, the principal bit starts to take over. If the interest rate was 15%, we would have an even more dramatic type of set of parabolas here, with the principal element and the interest always adding to the always adding to the fixed amount. So in this case, 1,517. If we reduce that back to the 5%, the monthly payment is 644. And if the interest rate was, let's say, very small, the monthly amount is small and most of the payment is principal, even at the beginning of the life of the mortgage. Okay, so that's some of the dynamics. Now, that actually took a little bit of work to set up, and I have a video clip outlining how to set it up, and I'll leave a link below this video clip, how you do all this in Excel. Might be good to have a function. So if we take the numbers that we have here again, copy, and then we create a new function, or just paste in the values that we have here and redimension our table. Okay, and this is set up as a sort of a manual estimation, and it was 5%, right? Okay, now, because we have saved our function to amortize, we have amortize or amortize, and then go up to FX, and then we'll have the principal, the interest, and I think it should be, if I remember correctly, we have to multiply it by 100 here. We can check in a moment. We've the number of months is 360. The output, I think we were to say, was table. And I think we can say null. And that's it, okay. Okay, and we can see here, okay, so let's go back in. Doesn't look completely compelling. Let's change this back. Okay, and what we observe here is we have actually set out the mortgage payment, which is the 644, and the principal is 144.86, and the interest is 500, installment 1, 2, 3, 4, 5, and it should be going all the way down to 360, right? 260 months. Now we can compare against what we had before. And maybe I'll just eliminate for the moment view. And was this, maybe I should unfreeze panes. Okay, and just copy everything here from the VBA and the manual estimation. Right, so this is takes a little while actually to set this up and to pull it down. I'll leave a video clip explaining the steps involved. It's useful in its own right, but unfortunately it takes a long time, and this function here actually does it all together, the R function. So what I should do is paste special values. Okay, and we'll just widen these out and we'll compare our results. And what we observe here is payment, same, interest is the same, and the balance is the same. this value and this value are the same. Okay, and all the way through. Right, we're replicating the same results. Same here, and this is the same as this one here. And then the balance we carry is the same as here. So the function that we imported then is quite a nice function, and it does all the amortizing automatically, right? Doesn't involve setting up the manual estimation, which is actually quite onerous. Okay, so long as we know, I guess, what we're doing, right? Okay, so we'll go back into our Colab for a moment. And that function seems to work fine, and we're able to transpose it across. It works in Excel. It works here in the Google Colab. We're able to replicate this in into Excel using the BERT, and perhaps I should leave a link here to the Colab, in the Colab, to the BERT Excel add-in. Right, so we'll just put that underneath. So I'll just say BERT, B-E-R-T, Excel, add-in, link. And I'll also leave a link to some video clips I have explaining how to download and set that up as well. Last bit here is Thomas Girk's visualization. And I've taken the values here. So P is 500,000, interest rate is 6, L is 30, amortization true, and plot data. Okay, so basically, if we took the numbers we had before, the 120, and then it's 5%, 30 years, amort equal to T, plot data equal to T, and we run that. The visualization we get here is the interest and principal share of the monthly repayment, right? So it's 30 years, yeah. So the 30-year period, and these are annual amounts, right? So it's the annual interest and principal payment that we get. If the interest rate is very low, for instance, then principal would be mainly what's being paid. But if you have a mortgage where the interest rate is quite high, let's say the interest rate is 10%, then you can see we're getting most of the payment that's been made. Well, it's a lot bigger, start off with, but most of it is interest, right? So the dynamic behavior here switches. Now, interestingly, Fannie Mae, Freddie Mac have products that in the securitization process, they allow you to strip off the principal and the interest. So you have principal only and interest only securitization issues, and financial engineers, if you like, have for many years now been willing to sell the interest obligation and the principal obligation to investors. One could imagine if I was an investor and I wanted to receive a bigger share of the payout later, it would make sense to purchase principal only. And if I was an investor who wanted most of the repayment, if I lent money or if I purchased an investment where I wanted to front load the payment, then the interest only element here would work quite well. Okay, so that's just some food for thought, how the mortgage can be sliced and diced into the interest and principal only elements. And I'll leave that video clip there. I'll also, below the video clip, include in links to maybe more explanation how you build a spreadsheet, the amortization, and some of the estimates that I initially set up here ran in Excel.